Good morning, everyone. Today we're going to be talking about when systems of equations have either one solution, infinite solutions, or no solution. So as you may recall, if we were to graph two linear equations, meaning two equations that form straight lines, not squiggly ones or anything, we could tell where the solution was pretty quickly. It's right over here where the two lines meet. And in this case, it looks like that is going to be, -1, -2. Let's see. Yep, it's -1, -2. Now, sometimes they'll never meet. And we're going to see one of those today. And sometimes they'll always meet, meaning they're overlapping. And we're going to see one of those today, too. So, go ahead and make this graph. Don't write the orange part, just make this graph on your paper. If you want to, excuse me, this table. If you want to pause the video right here, that's perfectly fine. Okay, cool. So first we're going to talk about how you can find how we can tell on a graph right away that there's one solution to a system. Well, it's pretty simple. Those two lines, they only cross at one point. That's like this one we just saw right here. Now sometimes you have to be careful because if I started looking at this graph right here, I might go, well, their slopes look different, but I don't see them intersecting. It must have no solutions. Nope. If you're using a graphing utility, you should zoom out and make really sure that they never cross. Another way you can tell is check out the slopes. Look at how far one goes up and how much it goes across, and make sure that the other one goes up and across by a different amount. Because if they have the same slope, then there's not going to be a solution. If they have different slopes, I guarantee there will be one solution. Whether or not you can see it might be a different story, especially if you graph by hand, because you might just run out of room before you get there. Now let's see one solution when you're using elimination or substitution to solve. Well, that's when you get basically a regular answer. When you're using elimination or substitution, you get that x equals a number and y equals a number. Then you know that you have one solution. You'll be able to put it in this form where you say x comma y. And finally, if you're using slope-intercept form to compare them, you can tell fairly easily using that too. If you're saying, remember, slope-intercept form is y equals mx plus b. And just if you have different slopes, which is to say the m's are not the same number, you know right away that you have one solution. But you have to put it into slope-intercept form to be able to use that technique. Now let's see a situation where we have one solution. I'm about to show you some writing in orange. The orange stuff you don't need to write. You can if you want to, but it would be kind of long. So here's a situation that only has one solution. So there are two streaming services, right? Binge Watch and Stream TV. Binge Watch costs $7 a month, but Stream TV costs $5 a month, but they also charge a one-time fee of $5 for joining them. So if we look at that on a graph, we'll get, where is it? Whatever. This is one place we have to be careful, because at first, when we graph this, it looks like, oh, there's no solution, right? They never meet. But let's see, y equals 7x and y equals 5x plus 5. Those are definitely different slopes. if I look at how much my line goes up compared to over on this green one, I can tell it's definitely different than the blue. It's just a matter of going, they intersect way up here at x equals 2.5 and y equals 17.5. That means at the end of 2.5 weeks, you'd have to pay $17.50 just for being a member of either one. They'd cost the same amount in 2.5 weeks. Now, if we used elimination to solve that problem, we'd have to put it into standard form and say for stream TV, 5x minus y equals -5. And for binge watch, where they just charge $7 a month, it's 7x minus y equals 0. So if we add these two together, right? We would get, let's see, 5x plus, or no, excuse me, if we subtract these because the signs are the same. 5x minus 7x would be -2x, and -y minus -y, which is the same as saying -y plus y, we'd get 0, so that's -2x plus 0, and -5 minus 0. Well, it's still just -5. So we'd get -2x equals 5. Divide both sides by -2, and we'd find out, okay, x equals 5 over 2, aka 2.5. So that means at the end of 2.5 weeks, we would know that you'd pay the same amount. At that point, if all I want to know is infinite solutions, one solution, or no solution, I know there's one solution. If I need to know what that one solution is, yeah, I've got to take that x value and substitute it back into one of these, and then I can find y, which would be 17.5. Now, by using slope-intercept form, I could say, all right, y equals 7x for binge watch, and y equals 5x plus 5 for stream TV. Okay, they've got different slopes. This m is 7 on one and 5 on the other. I'm done. They have one solution. Now, if I want to find out what the one solution is, then I might have a little more work to do. I could probably use substitution once I had them in slope-intercept form. Now let's say infinite solutions. Infinite solutions is when it looks like this. At first, it just looks like it's one line, right? No, that's actually two lines. It's just that they're overlapping. So no matter where they are, they have the same values. That's why there are infinite solutions. So infinite solutions on a graph would mean they're overlapping lines. Which basically just means you drew the same line twice. Now if I've got infinite solutions to tell by elimination or substitution, that would be something where your last line of work would say 0 equals 0, or a number equals itself. And finally, in slope-intercept form, it's when you've got the same equation, where you've got the same slope and the same y-intercept. So let's see a situation that has infinite solutions. So both Tom and Lola join Stream TV on the same day. When will they pay the same amount? The answer is always. They're always going to pay the same amount. They joined the same streaming service on the same day, paying the same fees. So Tom's equation is y equals 5x plus 5, and Lola's equation equals 5x plus 5. So if I'm trying to figure out by slope-intercept format, I can say, okay, same slope, same y-intercept, they're the same line, it's infinite solutions. If I'm using a graph, well, I would know once I drew the same line 2 times. And if I'm doing it by elimination, then You don't necessarily have to put it in a standard form, but it can be helpful. So let's see, 5x minus 5x is 0, and y minus negative y is 0, and 5 minus 5 is 0. Oh hey, it's 0 equals 0. I know they're the same line. I know that there are infinite solutions. And now for no solution. That is when I have, on a graph, it's parallel lines, and they never intersect. So, like these ones. It can be hard to tell on paper. You have to make sure they have the same slope, which these ones do. And if you're using a graphing utility, you could potentially just zoom out and zoom out and zoom out until they look like the same line. I'm looking at 2000 something in my scale. Yeah, those have the same slope. They're never going to intersect. If I'm using elimination or substitution, and I get to my last line of reasoning and I get to 0 equals not 0. 0 equals anything but 0, or potentially some other number equals not that number. I know that it is a system with no solution. And if I'm using slope-intercept form, then I can tell right away if they've got the same slope or the same m, but, oops, same slope, but they've got a different y-intercept. You got to be careful because that's close to infinite solutions. Infinite solutions is same slope, same y-intercept. No solution, same slope, different y-intercept. B is different. Now finally, let's look at a situation with no solution. So Tom joins, excuse me, Tom joins binge watch, and Vanessa joins binge watch 3 weeks later. So for Tom, his equation is going to be y equals 7x. M equals 7, b equals 0. For Vanessa, her equation is going to be y equals 7x minus 21, where m equals 7 and b equals 3. Well, if I'm going by slope-intercept form, I can tell they're never going to cross each other because they've got the same slope, but their y-intercept, or b, is different. Now, if I'm going from a graph, it's a little bit harder, but you can tell if they have the same slope, which I can find by counting how many squares my lines go up and how many across between 2 points. And seeing that, well, this one has its y-intercept here, but the other one has its y-intercept way down here at negative 21. The reason that Vanessa's y-intercept is negative 21, by the way, is because right when she started, 3 weeks after Tom, he'd already paid $21 because he joined 3 weeks earlier, and it cost $7 a week. Now finally, if we use elimination, here are their two equations in standard form. We can say, okay, Tom's is 7x minus y equals 0, and Vanessa's is 7x minus y equals 21. Let's see, 7x minus 7x is 0, y minus negative y is 0, and 0 minus 21 is negative 21. And then let's see, 0 minus 0 is still 0. Hey, my last line of reasoning says 0 equals negative 21. That makes no sense. Which means I know that, okay, I've got 0 equals not 0. So by elimination, it's no solution. Thank you.